Welcome to Programming Rainbow. In this video, we will continue on the series of Don't Eat the Yellow Snow in SDL2 and C++. This is the 9th video, so if you're just starting out with this one, you can go to github.com, Programming Rainbow, Yellow Snow, CPP, SDL2. You can git clone that repository, move inside the directory, open it up with whatever editor you'd like. So I'm going to show you the final project real quick, just so you can see what it looks like. I've already compiled it before I started this, so I'm just going to run it. So we have the snow dropping here, and we want to collect all the white snow. We get a point for each one, but if we eat the yellow snow, the game is over, and we can press space to restart it, or we can press escape to close it. So this is the 9th video. We're going to be adding sound in this video. The last video we added the score. If you're just starting out with this one, we are working in the SRC directory, so you want to grab the code from the 8th video number 8 directory. You can copy that directory and rename it SRC, delete this one first, so you can follow along with this video. Otherwise, you'll be using the code from video 10, which is the final code in this project. So that's what's in the SRC when you clone the directory. Okay, so we are following on from the 8th video right now. And let's close this. So we are adding something new this time. Like the last video, we added the TTF, the true type font. This video, we're adding the mixer module. We're going to initialize it very much like we have the other ones. We are going to make a flag, and I'm going to use this mix init og. But this is just going to be exactly the way that we set up the images one, where you can OR them together and you check it. We're going to be doing the exact same thing. So I'm not going to explain all of that. I've already explained it in the video where we initialize the image module. So the mix module is going to be the exact same thing. So we put the flags in, it spits the flags out of what the answer was, and then we're going to use that whole sequence of masking the answer that we want and then comparing it to see if it is the actual answer that we want. So this is it, and then so this is mix init, and the different thing about this module is it doesn't use capital MIX, it uses capital M and then a small ix, which is different than the other, than TTF and to SDL and to image. They're all using capital letters, whereas this one uses only the first M as a capital. However, any of the constants like these, they're actually all capitalized still, so it is a bit confusing. But just know that it's capital M and then small ix for the function calls. And to close it, to quit the mix, we have this mix quit. It's exactly like the other one, so I'm not going to talk too much about that. So let's set this up. So again, since this is exactly like the image one, I'm just going to grab that. So the way that it takes a flag and then masks it against the original flag and then compares it to see if that flag is valid is going to be the exact same. However, we haven't set the flag up yet, so let's do that first so we don't get any errors. So in here, let me just make sure what the flag type is. It's just an int, it says. Okay. So it's an int, and I'm going to use this mix init og because all the audio that I'm going to be using, both the sound effects and the music, are all three og files. So this one is int, and I'm going to call this mix flags. And this one is going to be mix init, and we want og. Okay, so that sets that up for us. We also need to pull in this module. So this is going to be include, and where is it? It's mixer.h. So that will give us access to everything in there. And that's all that we need to do here. So in here, like I said, it's exactly like this one. It's the exact same style. So I'm just going to yank that. So this one is MIX with only the capital M. And we called it mix flags. So we are calling this function mix init with the flags, which is our mix init og flag. and it's going to return something. And that return, we are using a single AND, which is a bitwise AND, which actually acts as a mask. So a bunch more information can come out of this function than we actually want to know. If we want to know, say, if the first 2 bits were set and the first 5 bits were set, we don't care about the first 5. We only care about the first 2. So what this does is it masks out. So if this one had the first 2 bits set and nothing else, well, this one also has the first 2 bits set and nothing else. So this acts as a mask. And all those bits that were not set, zeros, will fall through and be nothing. Okay. So this is masking. So imagine we say, hey, I want the first 2 bits set, and the output of this is the first and third bit are set. This is going to mask out that third bit because I didn't care about it at all. And it's only going to give me the answer to the first 2. But the answer to the first 2 was only the first one was set, not the second one. That was our answer out. So then we compare it. Hey, we wanted the first 2 bits, and it's not going to be equal. So I have explained this in the beginner's guide to SDL2. The beginner's guide to SDL2 and C++, I explained it, and I also explained it on the image one. So anyway, this is a bitwise AND. This is being used as a mask, and then we're comparing it to what we originally wanted. So our flags go in, an answer comes out. We use it to mask out the part of the answer we want to know, and then compare it to what we actually wanted. And this one will be mix get error. We'll say initializing mixer. So that's going to be that. Now we go into game, and right up here, last in, first out, we're going to say mix quit. That's going to deal with that. So now we should have our mixer coming online, at least the module part. We're not actually opening an audio device yet, and taking it offline. I'm going to go ahead and compile this since we were actually using the video 10 for what I showed you in the very beginning. I'm going to do a clean release on that. The debug doesn't work still because the SDL3 is broken in Arch Linux, and they're forcing everybody who's using SDL2 to actually be using SDL3. So this is running. We're just bringing the audio online. I just want to see if it's going to error or not. It looks fine. Okay, so the next thing that we need to do is we have this, let's see, we have initialized the mixer and we set up how to close the mixer, but we need to open audio. So we're not going to get any audio playback unless we set this up. So this is looking for a couple of parameters. It's looking for the frequency. This is something like if you're listening to audio or music files or anything, and you can have 44,100 kilohertz or 48,000 kilohertz or even like 22,050 kilohertz, whatever. That's what this frequency is. This other one is the format, which I don't really understand that much. It's just how it's set up for the audio system, I guess. And this one is the channels. This is channels as in left, right channel. That's stereo or mono, things like that. And then this chunk size here is dealing with, I've always explained this wrong, but it's like how much data before it clips. Let me just see. I'm going to explain it wrong. Audio buffer size and sample frames, total samples divided by channel count. Okay, cool. It's the number of sample frames, 1 for mono output, 2 samples for stereo, that are fed to the device at once. The lower the number, the lower the latency, but you risk dropouts if it gets too low. So anyway, what this is if you put a small number in here, actually some of the audio information doesn't get processed because it doesn't have enough time, and you get dropouts. This dropouts causes this crackling sound. So you don't want it too low. But if you make it too high, you'll perceive lag in the audio. There'll be lag between when the audio was supposed to happen and when you actually hear it. So I use 1024. It says 2000. I can perceive a lag here. I can't really perceive one, or it's not important at 1024. You could even try 512. But like I said, if you go too low, you're going to get a crackling sound. There's no default on this one. So it's either defaulting to one of these two. I'm going to use the 1024. But on these other ones here, even though it doesn't tell you about on this page that there are defaults, if we go into the header file that defines mixer, we can find some defaults. So here is the mix default frequency, which is 44.1. Now, again, you can just set this to whatever you want, but I'm just going to use defaults because I'm lazy and I want to use whatever they say is the best practice. But again, you can set yours to 48,000 if you want. This one as well, this audio, this is the format. I don't know much about this. Is it signed or unsigned and big Indian or little Indian? I'm just going to use their default. So I'm going to use this right here, mix default format. And I'm going to use this default as well. But there is no default for chunk size. So I'm going to set my own chunk size to 1024. Okay, so just know that these defaults exist, even though they don't talk about them on this page at all. Right here, we can drop in defaults for all of these except chunk size. So I'm going to set this chunk size because I forgot. So in main.h, I'm just going to create a const expert int for chunk size because this is just an int right here. So we'll call this what? Chunk size. And I'm just going to put this equal to 1024. And you can set it to whatever you want. You can play around with it, try smaller numbers, bigger numbers, see if you can hear the lag. Like you'll see the snowflake hit and then you'll hear the sound delayed kind of deal. Or you can put it at a lower number and see when you start hearing the crackling sounds. But I think this is a good starting point right here. So back into init, we have done this, but we need to do another step. We need to open the audio device. So it's kind of a two-step thing. So let's look at that again. This function right here. And it's returning an int. The int is 0 on success or -1 on failure. So we've kind of seen this before. And I'm going to use the defaults for the frequency, for the format, and for the channel. Okay. But again, you can put in your own numbers, or for this one, you're going to have to look more closely at the different options available for it. But the frequency, you could put in your own frequency. Channels, you could put in 1 or 2. I'm not really sure if it does like Dolby 7 point, probably doesn't. It's probably just 1 or 2. But I'm just going to use, like I said, the default. So we'll just wrap this in an if statement. And this one is mix, open audio. And the first thing we need is our frequency. So I'm going to say mix default frequency. And I wish that the documentation told you about that, but it's just hidden away inside of the header file, which is a bit weird. The next one we need is channels. And you could put 2 here or 1. I'm just going to do the same, the mix default. Default channels. There is another channel thing that is completely different than these channels. We'll talk about it in a minute. And sorry, I skipped the format. Mix default. Come on. It's format. Okay, so we got mix default frequency, mix default format, mix default channels. And the last one is the chunks that we set ourselves. So I'm going to say chunk size. And that was set in the main header file. I could put this as anything, if anything, or I could put not equal to 0. Anything like that will work. And we just need an error message here. So yank this one. And this one, I'm going to say opening audio. So error opening audio, it's still a mix thing. That should be good. I can actually just remove this and have nothing here. So if anything other than 0 comes out of this if statement, it triggers 2. You can do it however you want it. So we need to do the reverse of this, which is mix close audio. And I'm going to put this in the game. And I'm going to put it right above the audio quit. I'm going to separate it out. And nothing returned from this, and there's no parameters put into it. So now we have our audio online. We can start thinking about actually loading audio. So let's see here. I'm going to just close these as I go. Open audio. We've already done the close audio. So that's gone. Now there's two things that we can do. We can load wave and we can load muse. So load wave loads something called a chunk. This is used as a sound effect, not as like music playing in the background, but a sound effect. And I know it says wave, we're going to load an OGG, but that's just the name of the function. So you need the destination of the file that you're loading, and then it returns a pointer to a mixed chunk. So the chunk is a sound effect. And then and we'll wrap this in a smart pointer. So our custom deleter will be the mix free chunk. And we've already seen this before. This looks just like the destroy texture or free surface, anything like that. It's the same thing. It takes a chunk, it frees it. Okay, the exact same thing is happening with the music. This loads music. Again, it's going to be an OGG file and it returns a pointer to mix music. And we have the same thing with mix free music. So the name, it's free music and free chunk, but the load is load wave and load muse. So we've already seen this kind of stuff, and we'll be checking if the pointer is null or a null pointer on the return of those. And these are all going to be smart pointers. So let's start doing that. I'm going to put these in game. So these are just going to be unique. They're not going to be shared or anything like that. So I do have a unique pointer here. I'm just going to grab this. The type of this is going to be a mixed chunk. And the deleter type is going to be mix free chunk. And remember, it's capital M and then small ix. And so we're going to have a collect sound, a hit sound, and a music. So I'm going to call this collect. Let me show you these sounds that we have. So we have a collect OGG and a hit OGG, and then in the music folder, we have this winter loop. So these are our two sound effects, the collect and the hit. The hit is if we hit a yellow snowflake. The collect is if we get a white snowflake. And the winter loop is just the music going to be playing in the background. So I'm going to yank this again. Okay, so the next one is hit. And now this last one here is not a chunk, it's music. And it's going to be free music. And I'm just going to call it music. So we have these three. We need to set them to null pointer, just like we've done with background here. We're going to do the same thing. So we have it collect. Mix free chunk. Hit. Mix free chunk. And then the last one is just called music. Okay, so we have collect as a chunk, hit as a chunk, and music as music and we do not need this here. Okay, so in load media, I'm going to load all three of these because these are just part of game. Well, that's what we're doing in load media. So let's look at this real quick, the load function. So this is mix load wave, and we just need the file, and it returns it. And the other one is mix load muse, MUS, same thing, but it returns that. So we're just going to reset the collect. So mix load wave. And we just need the relative path to the sound effect. So the collect one is going to be in sounds. And then it's collect.og. So we just need to check the pointer. So I'm going to go up here, grab this. So this one's called collect. Again, this function will return a null pointer if it fails. Loading chunk. And this is coming from mix. I'm going to yank the whole thing and do it for hit. So that's hit. And the sound that we're loading is called hit. We're checking hit, and we're still saying loading chunk. So I'm going to do it again, but this one is music this time. So it's not the same. It's not a loading a chunk. So music, and the location, this one's called winter loop, and it's in music folder. So winter loop, music, and error loading music. This one is load muse, not load wave. Okay, so that should be fine on all of those. So what we're going to do is we're just going to call reset on these to forcibly choose how we're shutting it down in game, because we do want to control the order, simply because we need to take modules offline and stuff like that. So these smart pointers, I want them to go out of scope before we start closing the audio and quitting the music. So I'm going to add them above here. But I actually want to make sure none of the music is playing. So there is a halt music that just makes music stop playing. It takes no parameters and it returns a value. But I'm not going to check the value. I'm just saying, hey, if music's playing, halt the music. And I'm going to do that. And then I'm also going to tell it the channel. So we're going to talk about these channels in a second here. But basically the sound effects are played on channels. And it's not left and right channel like that. It's different. It's like there's 8 slots. You can play 8 sound effects at the same time. And you can choose what channel they're on. We're not going to choose the channel. What I'm going to do is put -1. For this particular function, it's going to halt all the channels. So this is just saying, hey, all sound effects, all of them that are currently playing, no matter what channel they're on, halt that. And it's also going to return an int that I'm not going to check. I'm not going to check this if it failed to halt the channels. I'm just calling this before I start freeing the audio. So there is a mix halt music and mix halt channel. But with the channel, I do need to put a -1 so it halts all the channels. So these are just function calls. Halt music. This needs nothing, just like that. And mix halt channel. This one I'm putting a -1 so it halts all channels. Otherwise, you can specify which channel you want to halt. But again, I'm not worried about that. I want to halt all the channels. So I'm going to do this just to be kind of I'm just being serious about how I clean up after myself, you know. You don't have to do this, but I think it's a good idea. So I'm halting the music before I start unloading the music. And I unload the music before I close this. That's why there is a custom deconstructor going on here. So with the audio, the last one that was in was the music. So this music reset. I'm just going to do that. This hit reset. This collect reset. Okay, so that stops our music and channels, unloads our music and our sound effects. And now we close our audio device and we quit the mixer. All of this stuff has been loaded and unloaded now. Now we can actually hear something. Okay, so to play a sound effect, we actually play a channel. It says play an audio chunk on a specific channel. Again, there's this is not left and right channels like stereo channels. This is channels as in like how many different parallel audio sounds that you can play at the same time. So I'm not telling the audio to play on the right channel, left channel. I'm just telling an audio to play. And then while that one is playing, while that sound effect is playing, I can play another one at the same time. But I can only play, I believe, 8 is the default. And I haven't messed around with changing that. I think you can change it too. I'm not really sure, but I believe it plays 8 sounds simultaneously before it, if you try to play a ninth one, the ninth one won't get played. And you can choose what channel to go on and you could keep track of this and everything else. And I actually don't care about any of that. I just want to play it. So this right here where you're choosing which channel to play it on, I believe you can just put -1. If the specific channel is set to -1, it plays on the first free channel. So I'm going to put -1 here. It's just going to say, hey, find a channel for me. I don't care 0 through 7 what the name of the channel is. It doesn't really matter to me. If you find a free one, put it on that channel and play it. This is the sound effect that we want to play. And this one is, do we want it to loop? And I think we just put 0 here. If we put a -1 here, the sound effect will play forever. But if we just put a 0 here, that means it's going to play one time and it's not going to loop at all. The looping is going to be 0. So that's what we're going to do. This is going to be -1. This is going to be our sound effect. This is going to be 0 because I only want the sound effect to play one time. And this is going to return whether it failed or not. Now, this is the problem. I'm not going to check this at all because if I have 8 sound effects and I try to load a ninth one on simultaneously while the other 8 are still playing, it's going to fail. And the way it fails is it just doesn't play the sound effect, which that's fine for me. If I say I were to hit 9 flakes before the last one stopped playing, it's just not going to play the sound effect for the ninth one. And that's fine. I don't want it to shut my game down and say something errored. So I'm not going to check this at all. So I'm not going to check. If you set up a complicated way to track your sound effects and everything like that, you can deal with this, but I'm not going to deal with this at all. So I'm going to completely ignore this because basically if it can't play, I don't really care. It'll play again the next time a sound play if it has room. Otherwise, I'm not going to tell it to shut the game down. This is kind of happening in the game loop, and I don't really check things like this in the game loop. I check them when I load them, but not when I'm playing it in the game loop. I will check when I load the music, though, but not the sound effects, because these will fail. They will fail to play. So if they do fail to play, it's not a big deal. It's common. If you were to run too many sound effects at once, it's common for it to happen. But anyway, so mix play channels, what we want, -1, our sound effect, 0 for the loops. Let's do that. So let's find in our code in game where we're checking our collision. So right here, if we have a white flake, we can just play our collect sound, right? So we would say mix play channel, and I want -1. So it gets the first available channel. And now for this one, we have a smart pointer. We have to unwrap it. So it's going to be this collect and then get. Yeah. And now for our loops, it's going to be 0 because we don't want it to loop. Okay, so that's pretty simple. That's what it's going to look like. And we're not checking the return on this. Now, if we get a yellow flake, we want to play the hit sound. That's like the bad sound effect. Like you got the yellow flake, not the white one. So I'm going to put this the same one, but we'll change this to hit. And that should be all that we need for our sound effects. And I don't need to clean it. I'll just run it. Okay, so I'm not sure if you can hear this. So it looks like I have my sound coming just through my speakers and to the video. Trust me that there is sound effects playing. I'm not sure what I set up wrong when I recorded this video, but the sound effects are coming out of my speaker. But they are working. And I get that ding, 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 and then like a dull sound when I get the yellow one. And they're working just fine. So the next thing is music. I'm going to remove this up here. I'm going to play the music kind of like in the init. I'm going to start playing the music in the init right here. And I am going to check the music if it fails. So it's mix play music, and we need to send in the music and the loops. Here's the play music. This one takes the pointer to the music and loops. And the loops are the same. What I'm going to do here is I'm going to put a -1. Doesn't say -1 anywhere, does it? The documentation's not great here. So on this loops, if I put a -1, it should play nonstop. The number of loops playing. Just trust me, if you put a -1 here, it's not listed, but a -1 here, just like in the chunk, causes it to loop continuously. So we're going to do that. So we need the pointer to the music, we need the loops, and we are checking the return of this. 0 on success, -1 on failure, just like other function calls that we've been doing. So I'm just going to wrap it in an if statement. So I'm going to put it at the bottom of this function right here. So this is going to be mix play music. I don't know why I didn't put that. I've been writing Odin, so it's a bit different. So mix play music, and we're going to unwrap the pointer to this music. And then how many times do we want the music to play? And I want it to play infinitely. So -1 is an option. Right here, we're just going to grab an error message from somewhere. How about a mix error message right here? Okay, so we'll have error playing music. Yeah, that works just fine. Error playing music. It's a mix error. That looks great. So now when we play the game, music should play. We'll turn up the audio a bit. Maybe the microphone will pick it up. So the music's playing. We have our sound effects, and that was our yellow. And the music should stop when the game's over, I think. So we need to deal with that. So we already know how to halt music because we've done it in the cleanup right up here. So I can just grab this right here, yoink. And then down here, when we get the yellow flake, I'm just going to halt the music. But then we have a problem when we reset the game, we need to replay the music. And so my reset right now is not returning anything. What I'm going to do here is I'm going to grab the same thing. So in the reset, inside of the is playing, That should start our music back up again. Okay. I'm going to hit the yellow flake and the music has stopped. I'm going to press spacebar and hopefully the music restarts. Yeah. Perfect. So the other thing I want to do is you might not want to listen to the music. So I put in kind of a mute option to mute the music. The sound effects will still play. I mean, if you don't want to hear the sound at all, you could just turn your volume down or mute your device or whatever it is. But maybe you just want to hear the sound effects but not hear the music playing. So just added a mute toggle kind of deal. So we're going to add a bool to the game class. I think I just called it muted. Yeah. So muted, and I'm just going to put it false up here. So it's not muted. This is just a bool to help us keep track the music is muted or not, because we can't just mute and unmute the music as a toggle because we don't know if the music is playing or not, because if the game is not playing, then the music is not playing. So if we were just to mute and unmute the music, that doesn't work, because what if we unmute it when the music is not playing because the game is over? So we need this kind of toggle or this boolean here to decide when the music needs to start playing again or not. Oh, I needed to add in this method. So under reset, I'm just going to call it toggle mute. Okay, that should be what we need there. Okay, so first we want to know if we're muted or not. Okay. If we are not, I'm going to do the else one. So if we are not muted, it's very easy. We're just going to mute the music. I'm not going to halt the music. I'm just going to mute it. It doesn't matter if the game is playing or not playing. If the music is not muted, we're muting it now. And so to do that, we're going to do two things. We're going to flip the toggle, and we're also going to mute the music. Now, if the music is not playing and if we mute the music, nothing happens. It doesn't matter. But we did change the toggle. We have this pause music. So I'm just going to use this. This will allow the music to pause right where it's at in the music and keep playing. Now, every time the game is over, the music actually stops. And so it restarts from the beginning. But if we are just playing the game and I pause the music and then I unpause it, it's going to resume where it was. If I mute the music while the game is over and then I start playing the game again, the music will still be paused. We're going to set that up. But if I were to unmute it while the game was over, it doesn't matter because the music's not playing at that time. And the music's going to start from the beginning. So this only matters while music is playing. It allows us to pause and unpause the music. If the music's not playing, nothing happens. So we're doing this right here. It takes nothing. It returns nothing. It's just mix, pause, music. So like I said, I'm going to do two things. I'm going to set the Boolean. This muted equals true. And then this mix, pause, music. And that's all that we need for that. Because like I said, it doesn't matter if the music's playing or not. If it is playing, it's going to pause it. If it's not playing, it's not going to do anything. But we are setting the toggle. So that one's simple. It becomes a little bit trickier when the music is muted and we're unmuting it. This becomes different. So this muted equals false. But then what do we do? So we need to find out if the music is actually playing or not. Because if it is playing, we can resume it from the pause. But if it's not playing, then we need to know if the game is running to start the music. Let's check is playing first. So if this is true, so I have this on the else. First, we'll check if the music is playing. And we have a function for that. Right here, mix playing music. This isn't play music, it's playing music. And it's actually returns non-zero if music is playing, otherwise zero. So it's just basically, if the music is not playing, it returns zero. Otherwise, it returns something else. It's just checking if the music's playing. So if mix playing music. So if the music is playing, but it's in a paused state, we can resume it. Mix resume music. Now on the else, we have to check if the game is running. If we have it paused, and we're unpausing it, but the game is not actually playing, we don't need to do anything. We've already set the Boolean toggle. We don't need to do anything else. But if the game is playing, but the music is not playing, that means it never started playing, then we need to start the music playing. And we're just going to use this right here. Yeah, that's why I did the other one first. It's a bit goofy. Let's try this out and see what happens here. Now, we need to set this on an event. So I'm going to put it on the M key. And it's going to call toggle music. So put it on the M key. Toggle mute. Okay, let's try that one. Okay, I'm gonna pause, mute the music. Now I'm gonna resume it. Yeah, it is resuming in the same spot. So I'm gonna mute the music and I'm gonna end it. Now I'm gonna unmute the music and now I'm gonna restart the game. And we have music. Okay. So there, the music was playing. Now I'm gonna mute the music and start the game again. So there should be no music. And there is music. So I messed up. Let me try it again. Yeah. So there is something goofy happening here. Where's the mute? Oh, I know what's going on. So this is fine. It's the reset. Where's the reset? On the reset, we're not checking to see if it's muted or not. So we need to put a check here. We need, if it's not muted, to restart the music. So I'll use a bang and I'll say this muted. So basically, if it's not muted, we need to restart the music. Otherwise, we don't restart the music. Okay, let's try this again. Okay, so I'm going to mute the music. Now I'm going to end the game, restart the game, and there's no music. Okay, now I'm going to unmute the music. There's no music right now. And it's playing. Cool. I muted it again. I'm going to stop. I'm going to unmute the music. Now I'm going to reset the game. Okay, looks like its mute is working correctly now. Even if I mute it while the game's over or unmute it. So if I unmute it while the game is over and restart, that's fine. If I mute it while the game is over and then restart, there's no sound. That's great. Yeah. That is overly complicated way of muting the music because I'm dealing with the fact that the music may or may not be playing and I may or may not need to start the music playing. Yeah, that's why I did the whole Boolean thing. Okay, so I think that's everything. I'm just going to run back through what I did real quick. In the main H, we've added in the SDL mixer, so we have access to all the mixer stuff. We have created a new mix flags, which is just mix init og, but you can use a bitwise or to add other, if you wanted to more than one. Just like I explained in previous videos on the image one, it's the same. But we're just setting one because all my audio files are OGG for this project. And we have also added in this chunk size right down here, which is 1024. You can lower this if you like. But again, if you hear crackling, you've lowered it too far. Yeah, that's everything for there. So in init SDL, to bring the mixer online, it's mix init, and we're doing the same way that we've done with the image before, where we have the flags we want. We're masking out the flags that we want from the answer, and then we're seeing if we in fact did get the flags we want. And that's mix error. But we also need to open this mix audio. And I just used the defaults, which this is 44100. This is, I forgot, signed 16-bit int or something. And this is 2 for stereo channels. And then this is the chunk size. I use the default on those and then the chunk size that I set up myself. And this is mix open audio. So to bring these offline in game, the mix close audio is happening first and then the mix quit. That's how we bring them offline. So we have added some unique pointers for chunks. There are 2 mixed chunks and 1 mixed music. And the custom deleter is mix free chunk and mix free music for those. So we have those 3 unique pointers. And then in load media, we are loading them. And it's mix load wave, all capital on the wave, for any kind of audio that we're loading for a sound effect. So we're using the smart pointer reset for this and the collect sound we're loading. And we're checking the pointer to see if it failed. So that is on the chunk. The same thing here on the hit reset. On the music, we're using a slightly different function, mix load muse, to load a mix music file. And same thing. We're checking the pointer if it's failed or not. So we are resetting these so we can control the shutdown so that they happen before these things happen. We are also using this mix halt music to stop the audio from playing. And then we are using mix halt channel to tell all sound effects channels to stop playing. That is how we're cleaning up all the audio. Now, how do we use this? We go down to the collision. Anytime there's a collision with a white flake, we use this mix play channel. If we use a -1 here, we can pick the channel we want it to go on, but if we use -1, it finds the first available channel. If it doesn't find a channel, it simply doesn't play, and it would return an error. But it's not a big deal. Since we're not checking the error, it would just not play. And the next time there is an available sound and this function is called again, it will play that next time. So -1 is on first available channel. This is the sound effect we want to play. This is how many times we want it to loop. And I don't want it to loop at all, so it's just playing one time. We're also doing a similar thing for the yellow flake, but we're using a different sound. And when we do the yellow flake, since we were playing music at the time, we halt the music. So up here, we are playing the music in our init method. And this one returns 0 on success or something else, -1 or something on failure. So right here we're saying mix play music. This is the music file we want to play, or the smart pointer. And this -1 says play it infinitely, so it'll loop forever. And we are checking error on the music one. And you don't really have to, I guess, but I just did, but not on the sound effects. On the reset, since we are halting the music. On the reset, if we haven't set the music to be muted, we're restarting the music. Okay. Now we added this toggle here on the M key, and it calls this function right here. In the game class, we've added a muted Boolean, and I'm setting it to false in the initializer member list. So here, we're just using that. So by default, it's not muted. So if we were to press this, if it's not muted, it's going to go down here and it is going to set mute and it's going to pause the music. It doesn't matter if the music's playing or not, it'll pause it if it is playing. Now, this music, if it's playing and paused, it's still counted as playing. So if the music is playing, but you pause the music, even though you don't hear the music, it's still counted as playing. If we halt the music, it's no longer counted as playing. So this one, when it checks if the music's playing, this is checking if it's paused and it's resuming. So are you playing but paused? Okay, resume. Now, if you're not playing, is the game playing first? Okay, if the game is playing, we need to start the music playing. This one, we don't need to see yet if the game's playing or not, because if the music is playing, the game is playing, because the music gets halted whenever the game's not playing. So it's a bit complicated here, but basically this first one, I know the game is playing because the music is playing. The second one, I don't know if the game is playing or not, so I need to check if it is playing and the music's not playing. That means we need to start the music playing. So that is how we're toggling our music to resume or to start playing. Yeah. And that should be about everything. I hope I didn't miss anything. But remember, it's kind of like last in, first out with all this stuff. I'm resetting these pointers here to clear the memory before I start shutting down the sound. And I'm also halting the music before I start clearing the memory. Okay, so that is how you do sound effects, and that is how you do music in SDL. You can only play one music at a time, and I believe by default you can play 8 chunks at a time simultaneously. However, I'm sure you can change that. I haven't messed with that, but I don't think that's set in stone 8, but I think by default it is 8. So I hope that was entertaining or you learned something, and thanks for watching. Have a good day, and I'll see you in the next one. Bye.